I don't care what happens. I'm here to bring the truth at whatever cost that comes with it.
Logically, it makes the most sense that 1 times 1, and then that's where the mathematical convention comes in.
We multiplied it, we cubed the number, and then we divided it by 2, and we cubed it again and divided it by 2, and we did that a number of times, and that number still remained the same exact number, which we know cannot happen.
Terrence Howard, typically known for his acting career, has recently made a startling claim that is shaking the foundations of mathematics. Using only a basic calculator, he revealed abnormal loops that challenge conventional mathematical principles, igniting heated debates among experts. What if our entire comprehension of science and economics hinges on the error that 1 times 1 equals more than 1? Join us as we delve into why, if Howard's math is correct, everything we've learned about math might be fundamentally flawed. The forgotten equation. Terrance says that multiplying 1 by 1 equals 1. He argued that since multiplication should increase numbers, the result of 1 times 1 should logically be greater than 1. This challenge to basic math principles has sparked debates far beyond simple classroom discussions, touching on the very way math influences real-world applications in science and economics, where accuracy is paramount. Howard demonstrated his theory using a simple calculator. He showed how, through certain operations, the calculator displayed what he referred to as loops. These loops, according to Howard, contradicted traditional expectations of mathematical operations, suggesting flaws in foundational mathematical concepts. Beyond merely pointing out these inconsistencies, Howard saw them as an opportunity to encourage a deeper examination of mathematical truths. He posited that if even simple equations could be proven incorrect, perhaps it was time to reconsider how mathematical principles are understood and taught. This radical viewpoint suggested that entire fields of science that rely on these principles might be basing their work on incorrect assumptions. These philosophical musings on the nature of truth in mathematics went further, implying that the reluctance to question basic principles could lead other scientific disciplines to unknowingly build on shaky grounds. By advocating for a re-evaluation of accepted mathematical truths, Howard was not just questioning numbers. He was challenging the academic community to reassess the foundations upon which many scientific conclusions are based. His call for re-evaluation and rigorous scrutiny of established mathematical principles serves as a reminder of the dynamic nature of science. Science is not just about discovering answers, but also about continually questioning how those answers are reached. Whether or not one agrees with Howard's conclusions, his approach exemplifies the critical inquiry that is essential to scientific progress. This ongoing debate about basic mathematical operations encourages a broader discourse on how mathematics is taught and understood. It prompts educators, students, and researchers to critically evaluate the logic behind established formulas and remain curious about accepted truths. Howard's challenge to a simple arithmetic equation has thus sparked a larger conversation about educational practices and knowledge pursuit in the scientific community. The discussion surrounding Howard's views on mathematics is a narrative about challenging the status quo and advancing knowledge through skepticism and inquiry. It underscores the importance of not just accepting established facts, but actively testing and questioning them to ensure they withstand rigorous examination. This narrative serves as a catalyst for rethinking how scientific methodologies are applied and how robust our scientific assumptions truly are. As such, it plays a crucial role in fostering a culture of continuous learning and adaptation in the pursuit of scientific and mathematical understanding. A realm where mathematics and theology intertwine, the square root of 2 serves as a curious focal point for challenging the foundations of arithmetic. When this number is manipulated, cubed, or doubled, it unveils inconsistencies that suggest potential flaws in the way multiplication and division are traditionally understood. The accepted rule that multiplying by 0 yields 0, yet dividing by 0 spirals into infinity, raises fundamental questions about the consistency of mathematical operations. This issue mirrors larger debates found in religious contexts, where faith often clashes with skepticism. Terrence Howard, an advocate for inquiry, champions the idea that true doctrines should be robust enough to withstand deep questioning. This concept, inspired by biblical narratives where questioning is encouraged, stands in stark contrast to the rigidity often observed in religious institutions that discourage such scrutiny. Howard posits that if religious traditions are indeed of divine origin, their veracity should be apparent, and their truths unassailable under rigorous examination. Turning his attention to elementary mathematics, Howard criticizes the simplicity of accepting that 1 multiplied by 1 equals 1 without questioning. He suggests exploring this principle through practical applications, such as trading weights or money, to see if it holds true in real-life scenarios. This approach leads him to probe not only the mathematics involved, but also the fundamental laws of physics, like the conservation of energy, which should provide a reliable framework for understanding the universe. Howard also delves into the integrity of biblical texts. He argues that if perfection cannot create imperfection, then any discovered flaw within the scriptures casts doubt on the entirety of its teachings. From this perspective, he views the universe as an extension of the divine, suggesting that humanity is inherently part of this divine essence. This idea transcends mere theological debate and implies practical consequences for individual self-perception and potential to influence the cosmos. Moreover, Howard claims to have uncovered fundamental truths that have eluded even the greatest ancient philosophers. He attributes these insights not to formal education, but to a deeper, perhaps instinctual understanding, suggesting a form of cosmic consciousness that carries knowledge across lifetimes. This notion supports his belief in a universe that actively responds to human intentions and actions, reinforcing the idea of a living cosmos attuned to human endeavors. His challenge to conventional wisdom extends beyond mere academic debate. It is a call for a comprehensive reassessment of how reality, both physical and metaphysical, is perceived. Howard advocates for questioning not just mathematical constants and physical laws, but also the sacred texts held dear by many. He urges a re-evaluation that considers a broader, more interconnected understanding of the universe, suggesting that enlightenment might require discarding some of our most fundamental assumptions. This radical rethinking is presented not as mere speculation, but as a necessary evolution in understanding that impacts everything from scientific principles to spiritual beliefs. As Howard navigates these complex discussions, he positions himself as a modern-day pioneer, exploring territories that blend the precision of math with the profundity of spirituality. His reflects a quest not just for answers, but for a new paradigm that embraces a more expansive view of the universe and our place within it. Where everyone wants to be noticed, another person has decided to challenge established scientific concepts with a mix of personal stories and deep philosophical ideas. This individual boldly claims to have redesigned the periodic table by adding elements that sound like they belong in a sci-fi story rather than a chemistry class. He even sent his revolutionary ideas to hundreds of universities without securing them with patents or copyrights, which allowed others to take credit for his work. Now, from the shadows of Hollywood, let's explore the powerful forces that shape our universe, a new dimension in physics and chemistry. He also explores economic theories, suggesting a novel way to manage money that bypasses traditional methods. This involves a philosophical view on multiplying and dividing financial resources, though it lacks solid analysis and numbers to support it. The conversation then turns to physics, particularly focusing on the universe's natural curves. He suggests that electricity and magnetism have specific directional tendencies, northeast for electricity and southwest for magnetism. This unique interpretation deviates from conventional electromagnetic theory and seems to be based more on personal insight than scientific evidence. The discussion gets even more complex with references to the flower of life, an ancient symbol. Our narrator claims to have solved it, not through typical academic research, but through insights gained in childhood and divine inspiration. He argues that traditional geometric shapes taught in school are just rough approximations of the true, complex shapes that he has discovered and patented. This bold claim seems to assert that he has figured out the underlying structure of the universe, correcting centuries of scientific misunderstanding. He also talks about Earth slowly moving away from the Sun and suggests that humanity will need to travel between stars to survive. He uses this scenario to argue against straight-line thinking in favor of curves, proposing that true paths through space and life are wavy and spherical. The narrative continues with a personal philosophy that blends science with spirituality. He sees himself as a direct creation of a divine force, endowed with perfect understanding from birth. This view extends to everything around him, even inanimate objects like a plastic water bottle, which he believes vibrates with divine energy. He finishes by claiming to have patented solutions to fundamental problems of the universe, suggesting that he has revolutionized physics and chemistry. He dismisses traditional scientific shapes like Platonic solids as mere approximations, claiming his curved shapes are the true forms of reality. This approach to science mixes genuine curiosity with personal beliefs and self-promotion. It might intrigue some people, but others might find it questionable because it strays far from conventional scientific methods and proofs. Whether these theories will hold up under scientific scrutiny is uncertain, leaving us wondering about the practicality and truth behind his bold statements. We are left with more questions than answers as we try to digest these extensive claims and philosophical musings. The blend of science with personal ideology makes it challenging to distinguish between innovative thinking and mere personal conjecture. The self-assured nature of these revelations might appeal to some, but the theories present a puzzling mix of unverified claims for those looking for concrete evidence and practical applications. The future of these ideas depends on their ability to stand up to the detailed examination and testing that true scientific theories must endure. The narrative unfolds with a person deeply entangled in the magnetic fields and the generation of electricity. This individual, a self-styled modern-day polymath, attempted to bridge ancient spiritual insights with contemporary physics. They proposed that the interaction of overlapping magnetic fields initiated spinning motions that supposedly led to the creation of electricity. This explanation, while intriguing, simplified the nuanced reality of electromagnetic interactions. This character also ventured into the realm of geometry, suggesting that ancient civilizations had artificially created straight lines where none inherently existed, particularly referencing the Pythagorean theorem as an average or a simplification. This stance challenged the accuracy and reliability of centuries-old mathematical principles that have consistently demonstrated their validity through rigorous empirical testing. Moreover, the speaker was portrayed as someone who had dabbled extensively in various disciplines, merging metaphysical theories with the tangible principles of physical science. They suggested that geometrical forms like the Platonic solids were not merely mathematical concepts, but fundamental elements that could unlock the universe's structure. Personal reflections revealed the speaker's previous career in acting, which, while successful, did not fulfill their deeper intellectual and spiritual cravings. Instead, they found their true passion in exploring the physical and metaphysical realms, proposing new theoretical mixes that sought to challenge the established norms of the scientific community. An upcoming book was hinted at, one that promised to question the foundational concepts of arithmetic and economics. This book purported to challenge the very notion of multiplication as understood in conventional mathematics, suggesting a revolutionary but perplexing new approach to understanding value and numerical relationships. The flower of life, an ancient symbol laden with supposed significance, was central to the speaker's discourse. They claimed this symbol held profound cosmic power, having been etched into the walls of ancient edifices and obsessed over by historical figures like Da Vinci and Newton. According to them, this symbol was a key to universal understanding, yet it had been misinterpreted by those who viewed it only in 2 dimensions. Criticism was directed at traditional scientific methodologies, especially the reliance on Euclidean geometry, which uses straight lines to describe the natural world. The speaker argued that this approach failed to capture the true complexity of nature, which naturally avoids straight lines and instead follows curvilinear paths and patterns. As the narrative expanded, it presented a critique of the rigid frameworks of traditional science, which, according to the speaker, had overlooked the intricate and dynamic forms of natural phenomena by adhering too strictly to linear and 2-dimensional models. The narrative suggested a shift from a simplistic and static view of the universe to one that embraced its inherent complexities and multidimensional aspects. This shift was portrayed as not just a scientific or intellectual change, but as a profound transformation in understanding the universe's very fabric. The speaker and theories invited the audience to reconsider established scientific doctrines, advocating for a broader, more integrated view of the universe that recognized the curved and interconnected nature of all things. While these ideas were compelling and challenged conventional wisdom, they often ventured into speculative realms, lacking the empirical support that forms the backbone of credible scientific inquiry. This narrative, rich in its challenge to the status quo, thus served more as an intellectual provocation than a definitive shift in scientific paradigms. From the realms of physics and geometry, let's venture into cosmic space and its hidden forces, cryptic energies that shape our world. A curious blend of personal beliefs and scientific speculation, an individual claims to have made significant discoveries in the seemingly empty space between celestial bodies. They suggest that this void is filled with elusive particles, which, until now, even sophisticated equipment like the CERN Collider has failed to detect. While the concept challenges conventional scientific understanding, it lacks the backbone of empirical evidence, leaving it floating in the realm of conjecture rather than confirmed science. This person integrates a mix of science, metaphysics, and their own spiritual experiences, suggesting that insights from a supposed past life have illuminated their current scientific endeavors. Such claims of past life knowledge influencing contemporary scientific understanding are met with skepticism in the academic community, which prioritizes data and reproducible results over personal anecdotes and mystical experiences. Further complicating their scientific narrative, they criticize historical figures like Leonardo da Vinci for their reliance on straight lines in geometric studies, such as those found in the flower of life. They argue that nature inherently prefers curves, loosely alluding to the scientific principle that the universe's fabric is curved. However, their explanations lack the rigorous mathematical precision that supports established theories like general relativity. The discussion veers towards human behavior and interactions, positing that these are governed by simple chemical reactions. This reductionist view oversimplifies the complex interplay of neurological and biochemical processes that underpin human emotions and interactions. They also offer an unconventional interpretation of electrical and magnetic phenomena, inaccurately describing these forces as adhering to geographic directions, an explanation not supported by any scientific evidence. Challenging the foundations of mathematics, they argue for a radical departure from Euclidean principles, believing that this would pave the way for technological and conceptual advances. This call for a mathematical revolution, while provocative, falls short of providing a viable alternative framework that could stand up to the rigor of current mathematical standards. Hoping to sway the scientific community, they claim their findings could fundamentally alter our understanding of particle physics and the laws governing the universe. They imagine a cosmos teeming with hidden particles and energies that could revolutionize our understanding of the physical world if acknowledged and validated by scientific authorities. These claims, delivered with a mix of conviction and revolutionary zeal, typify narratives common among individuals who believe they have single-handedly overturned well-established scientific paradigms. However, Scientific advancement typically progresses through meticulous verification and collaborative research, not through the isolated efforts of an individual, however passionate they might be. While the presentation is filled with grand ideas about redefining science and the universe, these remain untested and speculative without the rigorous application of the scientific method. For any of these theories to gain acceptance, they would need to undergo thorough testing and peer review, fundamental steps that validate new scientific ideas. Thus, despite the enthusiasm with which these ideas are presented, they remain on the periphery of mainstream science, awaiting the scrutiny and validation that all new scientific theories must face. The text delves into the confusing nature of certain mathematical operations, which, when applied to real-world contexts, seem to defy logic. It boldly suggests that there might be a need to question the entirety of mathematics and reevaluate traditional views on the Platonic solids. The proposal posits that introducing new wave conjugations could potentially offer a clearer understanding of how the universe functions, a hypothesis that leans more on hope than on proven scientific fact. Over the centuries, mathematics has evolved through relentless scrutiny and adaptation. Despite its flaws, it has stood as a robust framework for understanding the physical world. However, this piece introduces a radical notion that the foundations of mathematics might be inherently flawed, marred by human greed. This criticism extends to economic systems, which, according to the narrative, also suffer from foundational corruption due to their reliance on mathematical principles tainted by greed. The discussion of mathematical principles, such as the idea that 1 times 1 could equal 2, introduces a radical rethinking of balance and equilibrium. This rethinking is portrayed as an idealistic state of mathematical harmony. However, suggesting that 1 times 1 might equal 1 implies a loss within the mathematical construct, while positing that 1 times 1 could be 3 or more ventures into discussions of overunity and supersymmetry. These concepts don't just challenge mathematical norms. They raise profound philosophical questions about value, growth, and fairness. The narrative challenges the reader to consider whether it is necessary to overhaul our understanding of mathematics and physics simply because our financial systems, influenced by greed, show signs of failure. It asks if there is a need to rethink both the basic and complex constructs of mathematics and economics. These questions are not just academically intriguing. They hint at a desire for revolutionary changes that might seem impractical or overly theoretical. Moreover, if these revolutionary ideas were taken seriously, what practical steps would be necessary to implement such sweeping changes in both mathematical theory and economic practice? The concept of harnessing overunity and supersymmetry to make the universe work for you is presented as empowering but simplifies highly complex scientific principles to almost magical levels. Continuously challenging and reassessing our knowledge is crucial, but the approach suggested in the text seems more intent on provoking thought rather than providing tangible solutions to the alleged crises in mathematics and economics. The narrative mixes a critique of the existing systems with a visionary, albeit vague, belief in the transformative power of new mathematical models to radically alter our understanding of the world. However, despite the theoretical appeal of these ideas, the pathway to implementing such fundamental changes remains unclear, shrouded in the complexity of redefining long-established principles. Having looked at cosmic forces, let's examine how our basic understanding of math and money might be flawed. The debate over traditional arithmetic. As the discourse unfolds, the reader is prompted to question the feasibility of such fundamental shifts. Are these ideas merely meant to stir the pot, or do they hold potential for real transformation? The narrative blends a critique of current systems with an optimistic, yet somewhat nebulous hope for a future where mathematics and economics are not only more equitable, but also more aligned with a cosmic order. Yet, for all its visionary allure, the practical steps toward such a future are not detailed, leaving a gap between revolutionary thought and actionable reality. A world governed by numbers and calculations There was a growing discontent among some thinkers who believed that basic arithmetic was being used to manipulate economic systems. They pointed out how simple acts of multiplication, when applied to monetary values, revealed discrepancies that went unnoticed by the general public. For example, when 2 quarters were multiplied, not as physical coins but as numerical values, 0.25 times 0.25, the resulting number on a calculator was 0.0625. However, a theory proposed that instead of this small fraction, the outcome should represent a much larger value, supposedly $6.25. This stark difference raised questions about how values were traditionally calculated and whether financial institutions were using these mathematical norms to their advantage. This suspicion extended to other small denominations such as dimes. Normally, multiplying 0.10 by 0.10 yields 0.01, a mere cent. Yet, some argued that this operation should logically conclude with $1 instead. They suggested that banks, exploiting the common understanding of mathematics, were drastically underrepresenting the true value of multiplied sums, thereby benefiting from the widespread mathematical ignorance. Such unconventional thinking led to a broader examination of how mathematics meshed with other fundamental principles like physics. Traditional math teaches that multiplying anything by 0 results in 0, and 1 multiplied by 1 is always 1. Yet, these basic truths were now being scrutinized. Critics questioned whether these mathematical laws truly aligned with the laws of physics, which include the principle of conservation, where nothing can come from nothing and nothing can turn into nothing. The debate even touched on philosophical ground, challenging whether the established mathematical rules genuinely mirrored the real workings of the universe. There were calls for a deeper audit, not just of financial calculations, but of the very roots of mathematics itself. People discussed the importance of re-evaluating the Platonic solids, the square root of 2, and the fundamental reactions that these principles dictated. Amidst these discussions, there was a sense of urgency. If these foundational beliefs about numbers and their operations were flawed, then perhaps humanity was at a critical juncture. Could society advance if its basic understanding of mathematics was incorrect? The potential for stagnation was real, and the implications were far-reaching. This wave of skepticism wasn't just an academic exercise, it was a call to action. There was a pressing need to scrutinize and possibly revamp the educational systems that taught these principles, as well as the financial systems that utilized them. The challenge was not just to question, but to understand and possibly redefine the way numerical values were comprehended and utilized across various fields. As this narrative unfolded, it was clear that the uncover and possibly correct these discrepancies would be complex. Yet, it was a necessary pursuit to ensure that future generations would inherit a world where numbers and their implications were both understood and fairly applied. The quest for truth in mathematics was not just about numbers, but about fairness, transparency, and the very fabric of societal progress. Terrence Howard proposes that these forces, typically viewed as destructive, are in fact essential elements in a grand cycle of creation and destruction that governs the universe. Howard suggests that these forces are neither inherently good nor evil. Rather, they are tools that facilitate the ongoing process of material transformation essential to cosmic dynamics. This philosophy sees all phenomena as originating from a singular creator, with science acting as a tool to uncover the workings of the natural world. Howard posits that by understanding the roles of magnetism and radiation in the broader cosmic order, one can enhance their faith, seeing these forces as part of a balanced system where destruction complements creation, ensuring the continuity and renewal of life. Further, Howard connects these theories to human health and the effectiveness of medical treatments. He tells of patients who have remarkably outlived their medical prognoses, suggesting their survival could be linked to alternative treatments informed by his understanding of these universal forces. These cases are put forward as evidence that mainstream medical science might be missing critical elements that align with Howard's broader views of nature. Despite facing significant opposition and skepticism from the scientific community, including several legal challenges that aim to discredit his practices, Howard remains steadfast. The failure to convict him, in his view, is testament to the potential validity of his theories, which challenge conventional scientific methods and perspectives. However, these claims by Howard require a leap of faith. His reliance on anecdotal evidence and philosophical speculation lacks the rigorous testing and validation found in scientific research. While his narrative is compelling and resonant with ancient philosophies of balance and cyclical life, the absence of empirical support casts doubts on the applicability of his theories in practical science. Howard's ideas provoke reflection on the nature of scientific acceptance and the criteria for evaluating new theories. The controversy surrounding his propositions illustrates the tension between innovation and established scientific protocols. It highlights the need for a scientific community that is open yet critical, capable of integrating new insights without compromising on methodological rigor. After questioning our numerical foundations, let's consider how these ideas could reshape our view of the universe. Curves against alien straight lines. The universe seems to have a sense of humor, where every solution we find creates a new problem. Imagine a man inventing a time machine to bring back his lost wife, only to realize that his loss was the reason he built the machine in the first place. His solution became his problem in an endless cycle. This man believed everything in the universe happened for a reason, seeing events as carefully planned. When his mother died, he didn't see it as a random tragedy, but as a wake-up call to reach his true potential. Instead of drowning in sorrow, he dove into the world of science, driven by the idea that he could help humanity understand the cosmic order. His ambition was to lift humanity to a higher state, a goal some might say was overly optimistic and ambitious. He suggested categorizing civilizations by their control over the natural world. A Level 1 civilization controls its planet entirely. A Level 2 manages its sun and solar system. A Level 3 dominates the galaxy. And a Level 4 controls the universe. These ideas, while exciting, seem far removed from our current abilities and could be seen as fantasy. How can we think about controlling a galaxy when we struggle to manage our own planet? He also questioned our basic understanding of space. He pointed out the contradiction between the curved nature of the universe and the straight lines we use in geometry. He suggested that our scientific foundations might need rethinking to truly embrace the universe's nature. However, this raises practical questions. Talking about waves and curves is interesting, but how does it help solve real-world problems? He encouraged us to think more holistically about the universe. However, his theories often seemed abstract, lacking clear steps on how to achieve harmony with the cosmos. By focusing so much on the grand scale, we might ignore simpler, more practical solutions that are easier to achieve. These reflections push the boundaries of our imagination, but also make us question if we are setting our sights too high. Are we aiming for a level of cosmic control that might be impossible? While his ideas inspire us to strive for greater things, they also make us wonder if we are reaching for something that might be an illusion. In a universe governed by the laws of physics, Newton's third law states that every action has an equal and opposite reaction. This principle suggests that, as force increases, so does the reaction, leading to increased resistance. This cause and effect chain makes one wonder about the origins of straight lines, especially in relation to perfectly geometric shapes like the Platonic solids. How can these flawless straight lines exist in a universe dominated by curves? Looking at human anatomy, we find more complexities. Fingers, which are versatile tools for interaction, are connected to the brain by the same nerves that link to the teeth. This might seem trivial until we consider that, in a way, teeth could be seen as another type of finger, trapped within the jaw. This opens a debate on the ethics of cosmetic dentistry. Why do we rush to replace original teeth with artificial ones just for appearance's sake? The human brain dedicates over 60% of its resources to controlling the hands. Yet, Most people prefer to use one hand over the other, potentially underutilizing half of their brain's capacity. If this preference were mirrored in leg use, where one leg was favored over the other, our mobility would be compromised. A young teenager questioned this and experimented with his body's capabilities. Initially right-handed, he challenged himself to write with his left hand. This was more than a test of dexterity. It was as if he had tapped into a dormant part of his brain, revealing new facets of his personality and thought. Encouraged by this, he tried writing backward. This confirmed the flexibility and adaptability of his cognitive functions and suggested broader implications about human potential and societal norms. These personal experiments highlight a broader narrative questioning the limits of human potential and the norms guiding behavior. Exploring hand dexterity and brain adaptability points to a cultural reluctance to challenge established practices and fully explore human capabilities. Such investigations prompt a re-evaluation of accepted norms and encourage a deeper understanding of what it means to truly use one's physical and mental capacities. This narrative reflects not only individual growth, but also society's evolution as it confronts and redefines human potential's boundaries. What if our societal norms are actually hindering our true potential? Share your thoughts, like, comment, and subscribe to explore more challenging ideas together.